Good morning to all of you. My name is Dheeraj Kumar. My paper ID is 532. The title of my paper is Multifunctional JDLMS Control Single Phase Grid SPV System. Before starting my presentation, on behalf of all the authors, I pay thanks to organizing committee for selecting our paper for this conference. Content Introduction, schematic system, control system, simulation result, experimental setup, experimental results, conclusion, and references. Introduction. The cost of solar photovoltaic module has drastically decreased from Rs 200 per watt in 2010 to less than Rs 9 in 2024. The cost of lithium ion battery has also decreased by 40% from 2020 to 2025. Design various topology with grid connected solar photovoltaic as like a single phase, three phase, with and without battery storage component are presented in this literature. As various type of nonlinear load connected at the point of common coupling in the system inject noise cause losses, due to which cost of energy consumption also increase. To overcome this issue, various adaptive algorithms are proposed in various research papers to obtain amplitude of active weight component of load current, like LMS list mean square and an LMS based adaptive algorithm has less complexity, simple to implement, but its dynamic response are poor as well as take longer time to settle in the steady state condition. In the presented paper, an improved LMS is proposed and addresses as zero attracting least mean square algorithm, which is fast adaptive algorithm. The presented paper has effective for grid-connected SPV with battery backup with battery backup system and non-linear load. Schematic system. In the figure 1, a schematic diagram of single-phase grid-connected solar photovoltaic system is presented. Here we see that at the point of common coupling, grid, non-linear load, and a single-phase VSC is connected. In a single-phase VSC is connected with the interfacing inductor LF. A RC filter is connected across the grid, which next at the DC link side at a bidirectional DC-DC converter and a solar PV system is connected. Control system. Figure 2 VSC switching for purpose JDA LMS based controller. Here the control system is represented. Equation 1, the error of the proposed algorithm. Equation 2, the fundamental weight of a proposed algorithm. And equation 3 is the weight of a battery component. And equation 4, the weight of a PV system. After implementing this algorithm, we finally get the VSC switching for single phase like S1, S2, S3, S4. Simulation result. In figure 3.4, simulation result of proposed ZA LMS based controller under load perturbation is recorded. In figure 3, load current is perturbed at 0.25 and corresponding change occurs like error, fundamental weight also change. But unit template is performed, unit template and generation of grid reference current also maintain sinusoidal with increased magnitude. And whereas in figure 3, the response of grid voltage, grid current are out of phase, which means that and also battery current is showing positive, which means that battery is in discharging mode and it is feeding power to the grid, that is vehicle to grid mode working. Here a load is perturbed but is still the out of phase, which means that battery is again discharging and whatever the power generating the SPV is also feeding to the grid. Simulation result in 5.6. For under change in insulation, as a insulation change take place at 0.25 second from 1000 watt to 500 watt. Here load current maintain constant, error is as load maintain, so same error is maintained, fundamental weight also maintain. As a 0.25 second insulation change occur, but here see that VG and IG are again out of phase, that is and here notice that grid current again positive, that means battery current is again positive, that is battery again discharging and again feeding to the grid. Also whatever the power generating of through the SPV if meeting the demand of load and feeding to the grid, that is VG and IG are out of phase. Simulation result in figure 7. Simulation result of proposed JDA LMS based grid to vehicle mode and vehicle to grid mode operation. Here grid to vehicle mode, that is grid is feeding power to vehicle, that is VG and IG are in phase, due to which battery current showing negative, that is battery charging. A transition takes place between 0.5 to 0.55 second from grid to vehicle to grid mode. That is vehicle is battery is feeding to power to grid, that is VG and IG are in out of phase, and due to which current or battery current showing positive, that is discharging. In figure 8, comparative analysis of ZA LMS with LMS and LMS. Here we can see that here see at 0.25 0.4 second load is perturbed, due to which fundamental weight of a proposed algorithm is fastly settled at point 0, whereas other algorithm is in progress. When at 0. At time 0.8 second, load is again turned on. Load due to the response of ZA elements is faster and settle in a steady state quickly, whereas other is in progress. Figure 9, prototype setup developed in lab, that is experimental setup which is developed in the lab. Here the some instrument we used like host PC, one of the controller D space 1202 used, single phase VSC here. Here the PV simulator which is emitter based, and load is also connected here. The various type of sensor is voltage sensor, current sensor also used to record the result we use in the MSO. Experimental result, figure 10, the proposed parameters, the experimental results of parameter of ZA LMS controller. Here we can see that a load current is maintained, error is maintained, and unit temple also is showing per sinusoidal, and weight of the total weight is maintained. Experimental result of IL, IG, VG, VDC during the load perturbation. At load perturbation take place due to during which grid load current is reduced, whereas grid current is increased. Here they see that grid voltage is maintained, where the DC link voltage is also constant. Experimental results of in figure 12, experimental results of PV current, grid current, load current, and VDC as solar insulation 1000 watt per meter square. Here the as power generation solar at 1000 watt meter square, grid current is showing sorry, PV current is here somewhere 200 watt 200 ampere per division, grid current where the load current and VDC length maintain constant. In figure 3, MPPT at 1000 watt per meter square, it is showing approx 99%. Figure experimental result, figure 14, grid voltage and grid current. Here clearly seen that VG and IG are out of phase, that is the power is feeding to the grid. Also TIG analysis here seen, the grid voltage TIG less than 5%, grid current TIG less than 5%, and power of grid is showing negative, that means power is feeding to the grid. Conclusion, a single phase grid connected solar photovoltaic system has been presented in this paper for multifunctional operation. A zero attracting list means fast adaptive algorithm based advanced controller is simulated, then validated through experimental prototype set for effective performance under varying dynamic conditions. A current control adaptive algorithm used in ZA LMS base controller with addition of cost function improves the controller in terms of quick dynamic response, fast conversion, and quick to setup. The verification of result is carried out at various test points in simulation and experimental which perform satisfactory results. These are some references which helps to find out to complete this paper. Thank you for your attention.